Hi, welcome back to Data Mining with Weka. This is class 2. In the first class we downloaded Weka and we looked around the Explorer and a few data sets. We used a classifier, the J48 classifier. We used a filter to remove attributes and to remove some instances. We visualized some data. We visualized errors in classification errors on a data set. And along the way we looked at a few data sets, the weather data, both the nominal and numeric version, the glass data and the iris data set. This class is all about evaluation. In lesson 1.4 we built a classifier using J48. In this first lesson of the second class we're going to see what it's like to actually be a classifier ourselves. And then later on in subsequent lessons in this class we're going to look at more about evaluation, training and testing, baseline accuracy and cross-validation. First of all, we're going to see what it's like to be a classifier. We're going to construct a decision tree ourselves interactively. So I'm going to just open up Weka here, the Weka Explorer. I'm going to load a data set, the segment challenge data set. Segment challenge.arf, that's the one I want. And we're going to look at this data set. So let's first of all look at the class. Class values are brick face, sky, foliage, cement, window, path and grass. It looks like this is kind of an image analysis data set. When we look at the attributes we see things like the centroid of columns and rows, pixel counts, line densities, means of intensities and various other things, saturation, hue, and the class, as I said before, is different kinds of texture, I guess, brick, sky, foliage and so on. So that's the segment challenge data set. Now I'm going to select the user classifier. The user classifier is a tree classifier and we'll see what it does in just a minute. That's the user classifier. Before I start, this is really quite important, I'm going to use a supplied test set. So I'm going to set the test set which is used to evaluate the classifier to be segment test. The training set is segment challenge, the test set is segment test. Okay, now we're all set. I'm going to start the classifier. And what we see is the window with two panels, the tree visualizer and the data visualizer. Let's start with the data visualizer. We looked at visualization in the last class, how you can select different attributes for the X and Y. I'm going to plot the region centroid row against the intensity mean. There we go, that's the plot I get. I should make this a little bit bigger, I think. Okay, so now we're going to select a class. I'm going to select a rectangle. So we're going to select a rectangle, and if I draw out with my mouse a rectangle here, I'm going to have a rectangle of that's pretty well pure reds as far as I can see. Now I'm going to submit this rectangle, and you can see that that area has gone and the picture has been rescaled. Now I'm building up a tree here. If I look at the tree visualizer, I've got a tree. I center this tree, perhaps fit to screen. So we've split on these two attributes, region centroid row and intensity mean. And here we've got sky. These are all sky classes. And here we've got a mixture of brick face, foliage, cement, window, path and grass. So we're kind of going to build up this tree. What I want to do is to take this node and refine it a bit more. So here's the data visualizer again. I'm going to select a rectangle containing, say, these items here and submit that. They've gone from this picture, and you can see that here I've created this split on region centroid row, another split on region centroid row and intensity mean, and here this is almost all path, 233 path instances, and then a mixture here. So this is a pure node we got over there. This is almost a pure node here. This is the one I want to work on. I'm going to cover some of those instances now. Let's take this lot here and submit that, and then I'm going to take this lot here and submit that, and now I'm going to take, maybe I'll take those ones there, submit that, this little cluster here, seems pretty uniform, submit that. Now I haven't actually changed the axes, but of course at any time I could change these axes to better separate the remaining classes, you know, so I could kind of mess around with these. Actually the quick way to do it is to click here on these bars, left click for X and right click for Y, and I can quickly explore different pairs of axes to see if I can get a better split. Now here's the tree I've created. I'm going to fit it to the screen, and it looks like this, and you can see we've kind of successively elaborated down this branch here. When I finish with this, I can accept the tree. Actually, before I do that, let me just show you that we were selecting rectangles here, but I've got other things. I can select a polygon or a polyline. If I don't want to use rectangles, I can use polygons or polylines, and if you like, you can experiment with those to select different shaped areas. There is an area that I've got selected. I just can't quite finish it off. Alright, I right click to finish it off, so I could submit that. So I'm not confined to rectangles, I can use different shapes. Anyway, I'm not going to do that. I'm satisfied with this tree for the moment, so I'm going to accept the tree. And once I do this, there's no going back, so you want to be sure. If I accept the tree, are you sure? Yes. So here I've got a confusion matrix, and I can look at the errors. My tree classifies 78% of the instances correctly, and it's nearly 79 correctly, and 21 incorrectly. That's not too bad, especially considering how quickly I built that tree. So it's over to you now. I'd like you to play around and see if you can do better than this by spending a little bit longer on getting a nice tree. And I'd like you to reflect on a couple of things. First of all, what strategy you're using to build this tree. Basically, we're covering different regions of the instance space, trying to get pure regions to create pure branches. So this is like a kind of a bottom-up covering strategy. We kind of cover this area and this area and this area. Actually, that's not how J48 works. When it builds trees, it tries to do a judicious split through the whole data set. At the very top level, it'll split the entire data set into two in a way that kind of doesn't necessarily separate out particular classes, but makes it easier when it starts working on each half of the data set, further splitting in a top-down manner in order to try and produce an optimal tree. And it will produce trees much better than the one that I just produced with the user classifier. And I'd also like you to reflect on what it is that we're trying to do here. I mean, given enough time, you could produce a perfect tree for the data set. But don't forget that the data set we've loaded is the training data set. We're going to evaluate this tree on a different data set, the test data set, which hopefully comes from the same source but is not identical to the training data set. So we're not trying to precisely fit the training data set, we're trying to fit it in a way that generalizes to the kind of patterns exhibited in the data set. So we're looking for something that will perform well on the test data, and that kind of highlights the importance of evaluation in machine learning. That's what this class is going to be about, different ways of evaluating your classifier. Okay, that's it. There's some information in the course text about the user classifier, which you can read if you like, and please go on and do the activity associated with this lesson and produce your own classifier. Hopefully you'll be able to do much better than me given 5 or 10 minutes. Good luck.